There we go. So last class we were introducing ourselves to this concept of inheritance, and where we were using it in our code was to create a base class for an inhabitant, and then have a NPC as well as a player that came off of that. So we decided that this class inhabitant would keep track of a name, a number of hit points, an armor class, and a strength, as well as the current room they were in, just like we had before. Then we'd have the ability to roll some stats for them and display them. And then we made NPCs, we built them in terms of inhabitants, as opposed to in terms of the default. The default would be object that would go in there. We don't actually have to write that if we want to create a class that's based on object, but it is assumed to be there. And just to give you that idea, if I come back over here, I think I have a picture. This is based off of the example I had over here, where we have an automobile, which is kind of like our inhabitant in our current example. And then we have a car and a motorcycle, and both of these are automobiles. So those are kind of like our NPC and our player in our example. So car and motorcycle are built in terms of automobile, where an automobile is built in terms of nothing, but that nothingness that we have there is actually an object. So what we ultimately have is a model that looks like this. We have in this red box here, we have the object class that's built into Python. So Python knows about this top level class called object. Then we created a class called automobile that inherited from object. Now our intention is to never create an automobile, or in our project, never to actually create a generic inhabitant. We want to create specialized versions of inhabitants. So in our model here, object is created by Python. We wrote this guy with the intention of never to directly use him. Instead, we indirectly use car, and we indirectly use it by making car inherit from automobile, as well as SUV inherit from automobile, because both of those guys are automobiles, but then they specialize themselves a little bit from that point. All right, and then in our example over here, an NPC specializes himself from a generic inhabitant by rolling stats that give him a hit points. I mean, right now, this is how they differentiate themselves, by rolling stats that give them hit points, armor class, and strength between, what do we say, 3 and 8? I think our baseline was 3. So this gives us the maximum of those stats, whereas we decided that the general player is a little tougher. And a general player gets up to 15 hit points, 12 armor class, and 10 strength. All right, so we just decided right now the way these two things are differentiated is that NPCs are a little bit weaker than players. Okay, so we built the core functionality into our inhabitant class for roll stats. It knows how to roll stats given the maximum hit points, armor class, and strength. And then when we build our specialized kinds of inhabitants, NPCs, and players, we call upon that guy with the correct parameters. Now, we also talked about the super keyword last time, where super is how we refer to our parent class from within our class. Self is how we refer to ourselves. Super is how we refer to our parent. All right, so if I'm NPC, super refers to the instance of inhabitant that is at my core. Whereas if I'm in inhabitant, super would be the instance of generic object that is at my core. All right, so really, if we think about NPCs are inhabitants, which are objects. So an NPC is all three of those, right? It's an NPC, but it's also an inhabitant, but it's also an object, right? But its most specialized form is that it's an inhabitant, and it's specifically an NPC. Okay, so this is our simple inheritance model that we're trying to depict here. Now, what we're going to do eventually, we want to get both inhabitants and our NPCs and players into our game, right? And maybe in the hopefully maybe by the end of the semester, we'll see if we get to that. We maybe want inhabitants to kind of, or I'm sorry, NPCs to kind of wander around on their own. They're kind of computer controlled, whereas players, we are controlling them, right? We've already done that where we can, move between the rooms and that kind of stuff. But it might be kind of neat for us to be standing in a room and all of a sudden an NPC walks in and has kind of a mind of its own. And we're going to talk about that through threads, multi-threading, when we get to it. Okay, but for right now, we want to kind of maybe move away from our map for a little bit and think about just how NPCs and players can interact. Because one of the things that we want them to be able to do inside of our game, let's say, is we want them to be able to fight to the death, right? So we needed these guys to be able to enter into a contest with each other where they fight each other. So we're going to create that model right now that we can then use inside of our game when we're ready for it. Okay. So if we're going to kind of design this model, let's go. Actually, let me show you something a little bit more here. If you see the initial example I used of automobile, car, and motorcycle, they differentiate themselves by just the number of wheels. But in a more complex model of this, we have a car which keeps track of a number of airbags and a number of seatbelts. And we have an SUV that actually keeps track of towing capacity. Right. So that might be if you have an SUV or you have a truck, maybe you don't care how many people you can fit in the cab. You care more about how big of things you can pull with it, or how much stuff you can put into the very back of it, like hauling around bricks and stuff. It's a work vehicle. Used to be a work vehicle. Now now it's just, that's the vehicle I fit in. So it's that's the thing. The fact that it can pull stuff is kind of an extra thing. But generally speaking, we might say, oh, when we buy a car, we might buy a car for the number of people that fit in it because the size of the family or something. Where a truck, that's less of the concern. Generically speaking, we care more about towing capacity. So in this example here, you see how we've differentiated cars and SUVs from themselves. Now notice here that we actually have another level of inheritance going on here, where an SUV is a car. So a car is an automobile, except it keeps track of number of airbags and number of seatbelts. And then we say, well, we have a specialized kind of car called an SUV that also cares about towing capacity. All right, so an SUV is a car, where a car is an automobile, where an automobile is an object. Okay, so we can create multiple layers of this with maybe one goal in mind. Let's see if I have it in here. I don't, so let's just put it in here. If we ask, what's the goal of, well, I'm going to say, what's a goal of object-oriented programming? So OOP, object-oriented programming. So if you're ever reading online resources and they refer to something as OOP, that's object-oriented programming is what they're talking about there. Okay. So a goal of this would be to minimize the duplication of code. In the ideal world, you would not write the same code in more than one place. So if you had 2 or 3 different kinds of objects that all shared that same core functionality, good object-oriented programming would say, make a generic object that has the core functionality and then inherit from that core object the 2 or 3 things that all share that core thing, so you don't rewrite the same code 3 times. Now, why might we not want to rewrite the same code in my example here 3 times? What's the disadvantage or advantages of duplicating the same code more than once? There's two obvious ones, I think. Go ahead.
Can be the right word, but basically you're just doing the same thing over and over again for no reason. You don't have to.
Okay. So why might that be bad? Kind of waste of time?
Yeah.
Waste of space, waste of storage, stuff like that. You know, the file size is going to be larger, whatever. Okay. Now, that's a true statement. And from a human efficiency perspective, we would say, well, you know, we don't need to do it twice if we only need to do it once, if we can get away with just doing it once. Now, realistically, as we've talked about earlier in the semester, yeah, we don't really care about memory anymore, right? We got gigs and gigs and gigs of RAM and a whole terabytes and terabytes of hard drive space. So who cares? We'll beat up on this computer all day long and he'll thank us and ask for more, right? So that's kind of the premise of computing now. But certainly that answer of not duplicating code would have been a major discussion point years and years ago. Something when you guys take the CSC200 class, the database class, and you're going to be looking at kind of an older, but still, I would say most popular kind of database is something called a relational database that uses multiple tables and you kind of create relations between those tables. Pretty similar to what we're doing here, right? Where you have one table that has kind of core stuff in it, then you have two other tables that both use stuff from that single table. So kind of that same mentality as we're dealing with here. And one of the major goals of relational databases was, don't store the same information more than one time. That type of thing. Relational databases came out in the 60s and 70s. And, so during a period of time where not duplicating data was really important because we didn't have enough storage to store a bunch of data to begin with, let alone the same data multiple times. That's less of a concern today. And one of the things, and if we get to the database portion in here, we'll be looking at, we'll look at a relational database, but I also want to introduce an object-oriented database, what's usually called a NoSQL database, where we don't really store things we store things as objects in those. So we're caring less about storage weight and more about convenient organization, that kind of stuff. All right, so kind of getting back to what we were talking about here is a goal of object-oriented programming is to minimize the duplication of code. Why? Well, obviously to make our file size smaller. It's never a bad thing. Okay, what's the other probably more important piece of this? Anybody have another suggestion on another reason why it's a good idea not to go ahead.
So I guess if you're trying to like access the program with another program and it like tries to grab three of the same things, but it's only looking for one thing, but it gets confused because it's trying to grab all three or something.
Okay. Yeah, I mean, so the suggestion was maybe the program gets confused as to which of the things it's grabbing. That would be the problem of the programmer. They wrote poor code that made it ambiguous or something. Okay, so really the thing is as we go and we manage our programs, and we're going to see this in our code here as we modify our world to now accept other kinds of inhabitants, and they may behave differently and that kind of stuff. But the idea here is that let's say we change a piece of core functionality. We add something to it. We find a bug in it and have to fix that bug. We'd much rather fix that in one place and not have to remember the 5 other places you did the same thing in your program, and you have to go fix all 5 places every single time you make a change. All right. So now the concept of that is, so that might be a goal of ours as programmers, is that, we don't want to duplicate code in more than one place unless we absolutely have to. It just doesn't make sense not to, or something like that, for whatever reason. And one of the reasons is to maintain that program. If we make a change to duplicated code in one place, we have to then change it in all the other places that code is then used. All right. And so one of the things you'll talk about in the software engineering class, which you'll take next fall, right? 370. You'll all have next fall. You take 250 next semester, then you'll take 370 next fall. So one of the challenges, well, one of the things you talk about in the software engineering class is this idea of unit testing and regression testing, where you set up, as you write your program, you also set up special functions for testing your program to make sure the various things you've written in your program behave the way you intended for them to behave. And most languages have something called automatic regression testing, as long as you've set up your unit tests the right way, where you can effectively say, okay, I've made some changes to my program, go ahead and run it against all my unit tests that I've already previously written. And the purpose of that is to what? Make sure that anything you just didn't break old stuff, right? So you kind of set up a collection of things that should work. Then you make sure they do work once you have written those features. Now, when you add a new feature, you set up another unit test to test that new feature, but then you also make sure all your previous unit tests haven't broken, right? That you didn't introduce a bug in there that you weren't really thinking about because you wrote the old code 6 months ago or something like that. So that's the idea of those unit tests. You spend a little bit extra time so like after we've written something, we kind of, spend a couple minutes testing it, making sure it behaves the way we want it to behave. We do that ourselves now just to make sure it does what it should do. Unit testing is the idea of capturing that test into a specialized function that can then automatically get called conveniently later on to make sure it still does what it was supposed to do. All right. So when we test something, if we just chose to always test by writing a unit test and then running that unit test to test it, then we've set ourselves up for a convenient way of retesting it in the future. That's one of the things you'll talk about in software engineering as you get into larger projects, especially collaborating with other people, that when a whole bunch of different people are making changes to the same code base, you want to make sure that individual changes don't break stuff. All right. So punchline over, here is that when we're writing stuff in an object-oriented manner, we want to minimize the amount of code we duplicate. There's probably a fine line there where it, you don't want to create an object just to save yourself rewriting the same single line more than once, unless it was a really complex math expression or something like that. That it's like, well, if I change this, I want it to change everywhere. But in general, like if it's just printing out the name or something like that, you could probably just duplicate that code and move on with life. All right, so we'll call that one of the goals of object-oriented programming. So now for what we're going to try to design here is when we think about, so again, we're thinking about our world here through the lens of objects. So if we have two inhabitants, they bump into each other on the street, it's going to be a fight, right? we're gonna have a fight on the street. Okay. If we want to kind of capture this in terms of objects, what we might do is, so we're going to call this guy Deathmatch. So we're going to kind of capture the idea. I need to move this. So a deathmatch, I need these things to stay out of the way. So a deathmatch might keep track of a player and an NPC. All right, so we think of a deathmatch as this object, almost a mode that our program is going to go into that's going to pit a player versus an NPC where they're going to fight each other back and forth until somebody kicks the bucket. All right, so we want to, whenever a player initially says the attack command, like right now the commands we're taking are like north, south, east, west for moving around our map. But maybe when they say they want to attack a target, what gets created is a death match. And the player and the NPC get added to this death match, and then the death match governs the fighting back and forth. Okay, that's kind of what we want to accomplish here. So we're going to have an object called Deathmatch. And this object's job, so this guy is built with a player and an NPC. Maybe later on, if we think about our modern video games, where you have PvP, where you can have players versus other players and fight. But we obviously are only going to take this so far with our obviously bestseller game here. We're going to make millions. It's going to be awesome. So we're going to say this guy is built with a player and an NPC. So the player is going to fight against the non-player character. All right. And sets up a back and forth battle between them where one of the inhabitants is chosen to attack first, and then they alternate attacks until someone dies. Now, we might say, what's an attack? Well, an attack maybe attacks come in 2 steps. One, see if your attack is successful by, let's call it by clearing the opponent's armor class. All right, so our armor class, if we think about this in like traditional Dungeons and Dragons-y type thing, is your guy is wearing a whole bunch of armor, some kind of different armor. You might have plate armor on, or scale armor, or if it's a wizard, maybe he's just wearing a robe, which obviously is not going to hold up that well to a sword attack, right? So the idea is based on the heavier the armor you have, the more natural protection it gives you. All right, so if you have a certain armor class, whatever it is, and somebody else takes a swing at you, it doesn't matter how skillful that swing might be. If it just bounces right off the armor and doesn't do any damage, then doesn't matter, right? All right, so the idea would be that each of our inhabitants kind of has a built-in level of toughness that we've called armor class. We haven't specified how they've achieved that other than just a random number, right? But in Dungeons and Dragons, you put on a plate helmet, you get a little bit more armor. You put on, other kinds of armor, shield, you get some more armor, that kind of stuff. All right, so one way or another, our inhabitants have this armor class that was given to them. And before we can actually see how much damage we do to them, we need to find out if we do any damage to them. All right, and that's going to come in the form of clearing their armor class. So the process of this is typically this is called the D20. If we're thinking about Dungeons and Dragons rules, we roll a 20-sided die, and if the result is at least as high as the target's AC, then damage will be done. Something along those lines. All right, then we'll say if the attack is successful, we need to calculate damage and apply it to the target's health through their hit points. All right, so how do we calculate damage? We will roll. Let's come up with, we don't want them to die too fast. So, this is just one shot. So maybe we roll a roll a d4 and add to it their strength. I'm going to call this their strength modifier. And what I mean by that, so typically in real Dungeons and Dragons, depending on what your strength is and depending what your race is and all these other things you have these extra modifiers. The stronger you are, the more extra oomph you have behind your attacks. Well, since we're not going to go too deep into that in our thing, what I'm going to actually do here is our second, is it or third, I think, is our stats. Yeah, strength is the last thing. What I'm going to do is I'm actually going to make our strength relatively small because I'm actually not going to store their actual strength. I'm going to store their modifier. So for strength, we'll roll between a 0 and whatever max strength was. And then we're going to say that NPCs are relatively weak. So we're going to say that their strength is between a 0 and a 2. And for a player, we'll say that their strength is between a 0 and a 4, something like that. Okay. So the idea here would be is instead of storing how strong they actually are, we're storing how much extra damage they do when they hit somebody. Their strength modifier, the amount of oomph behind their swing. All right. So I just modified this a little bit to have these guys, be weaker, because the most we would add to a swing from an NPC would be 2. The most we'd add to a swing from a player would be 4. Maybe we change that to a 3. So players don't hit that much harder. All right, something like that. So we would roll a d4 and get a value between 1 and 4, and then add to it a 2 in the maximum case, or a 1 or a 0, whatever it is, or a 0, 1, 2, or 3 in the case for players, depending on what that player's random strength modifier ended up being. All right, so we'll roll a d4 and add it to their strength modifier to get the damage that they did. All right, so that's what we're going to try to accomplish there, and then keep alternating who gets to attack and who gets to defend over and over until someone dies. Go ahead.
I'm not saying do this, but is it possible to have it work on like a time tick or whatever, so they could both technically attack at the same time, or like?
Yeah. I mean, so once we get into like multi-threaded stuff where they can kind of both, where the speed at which the player hits their says kill or whatever, the NPC could get 3 or 4 shots in, if the player's slow to attack.
Weapons,
Yeah, I mean, if you think about, sure, all these things are possible. So I mean, if you think about your modern video games, if your player runs up to one of the enemies and you don't push anything on the controller, the enemy's just going to keep swatting at you until until bad things happen, right? Until you step up and start doing it. So those two things are happening kind of simultaneously. But in our little example here, we're just going to alternate because we don't have some of the tools available to us yet for having these things potentially happen kind of at the same time through something called multi-threading, and then it also becomes a little bit difficult to do it at the and hopefully we'll see it. I mean, we do have a couple of weeks left, so it also becomes difficult to do it at the kind of the text-based game level. Usually we have the game kind of has this heartbeat where every tick, every heartbeat, something can occur, because we ultimately maybe want to have a situation where we're standing in the hallway and all of a sudden an NPC walks into the room. Well, so the idea would be maybe every single tick an NPC decides whether they're going to move, and if they're going to move, they randomly pick one of the exits near them to move into, something like that. So that adds a little like, oh, the environment is alive type situation, but we need some kind of cadence for how often that happens. and we can have a full game cadence that does that. If you're a game programmer, if you've done something with like Unity or interested in that kind of stuff, a lot of times this is called the game loop. So the game loop is, you know, every so often, it's usually based on frames per second. You have this loop. So maybe 60 times per second, this loop runs. And so that means up to 60 different times per second, stuff can happen, right? You can, you know, your guy moves from one place to another place, and animations are played, and that kind of stuff. Okay. But we're going to keep it fairly simple and just say, you know, we're going to pick who goes first, and then the and realistically, if it's going to be the player attacking the NPC, it's probably always going to be the player that goes first, right? He gets a cheap shot in, and then the fight breaks out. All right, but this is going to be what we're going to try to mimic here in our deathmatch. All right. So if we're thinking, if we start designing our deathmatch here, a deathmatch is going to be between a player and an NPC. So those are the two fields we'll create, where a player keeps track of their hit points and all that stuff, and NPC keeps track of their hit points. So there's more detail inside of these two things, but these are inside of this kind of the ring, if you will. Okay, so inside the deathmatch, we're going to keep track of these two things when we build it. We might also then decide who goes first. Maybe initially we'll just always assume the player goes first. Let's just go that route. Okay, so now we want to have the a fight function that has the player attack first and alternates until someone dies. All right, so that's what a death match is going to be. Build it with a player and an NPC, then tell that death match to start, say fight, and then it just plays it out. Okay, so let's go and start writing this guy. So I'll put this guy here up at the, actually, let's just put it right before inhabitant. So we'll put a class deathmatch here. And a deathmatch will inherit from normal generic objects, nothing special about them. All right, and then we'll define our constructor. This is going to be self, and then the player, and then the NPC. So when we build a deathmatch, we're going to be having a deathmatch between the player and the NPC. That's what it gets built with. Okay, and there might be in a single room, there might be a whole bunch of death matches going on at once. But we're designing the model in which a fight between a player, a single player, and a single NPC occurs. All right, and that's the only part of the world we're currently modeling. All right, so we'll set self dot the player equal to the player. Self dot the NPC equal to the NPC. So we'll save those two pieces of information. All right, then we'll go ahead and we're going to define another function called fight. And fight doesn't require any parameters because we're just going to say go, right? Turn on the fight. All right, and we're going to decide the player is going to go first, and the NPC is going to defend first. So what I'm going to do is I'm going to create a variable here called attacker, and we'll start this off as self.the player. And then I'm going to also create a variable called the defender, self.the NPC. Those are the initial values for those variables, and then we'll swap them each time through so that the attacker always attacks, the defender always defends, but the attacker and the defender will be switching places as we go through here. Okay. And we're going to keep doing this as long as the defender is still alive. Right? Now, actually, we should think about when we're going to do our swap. the person who last defended, they're the one who just got hit. They're the one who might die, right? But they're also going to be the next attacker. So really what we're saying here is while the attacker is still alive, because the current attacker was the previous defender who may have just died. Make sense? All right, so we need to now have the ability, so we want to say something like while while attacker dot HP is greater than 0, that means they're still alive. But I don't want to write it that way. Instead, I want both players and NPCs to be able to tell me whether or not they're alive. Figure it out inside, right? Because if we kind of fast forward, not that we'll actually ever write this, but there might be more to it than just their hit points. You know, maybe they have an extra burst of energy, or in Dungeons and Dragons, there's some fighters have a feat that allows them to like cheat death, where they get one more like dying swing type thing. So while they might appear to be dead, their hit points are at -3. They get one more swipe on the way down. Okay, so we want them to be able to tell us what it means for them to be dead, even though we're just going to do the same logic here. But since both players and NPCs are going to report whether or not they're dead, and for right now, they're both going to do it identically in that is my hit points, I'm dead if my hit points are less than or equal to 0. All right. We'll go ahead and put that in the inhabitant level, since both players and NPCs will get that, because we don't want to duplicate it. If I go inside here and I go into, would I put it right before inhabitant? Yeah. If I go into NPC and I write a function called def is dead, and this guy is going to return, he should return true if he's dead. That means that self.hp is less than or equal to 0. That means he's dead, right? Well, we can say, well, that's for an NPC. Well, what about a player? Well, a player is going to have the same deal. So we come into player and we write the same function. We would say that now we've written the same code more than once. Maybe that's not a good idea. Okay, because if I decide, well, actually, they're only dead if it's less than or equal to 2, for some reason. They fall unconscious. They actually lost the fight if they lose consciousness, and they technically could live to fight another day, but the other guy was nice enough not to keep swinging when the guy was just laying there unconscious. Okay, things are going to get very violent in here, just FYI. All right, so the idea is that, okay, well, now I changed it there. I need to also come down here and change it, since we changed the definition of dead. Okay, that's the problem from a little bit ago we were talking about that we want to avoid. So what we would do is we would get rid of the function at the player and NPC level, and instead put it at the inhabitant level. So now all inhabitants automatically get this is dead function. And if we decide that, oh, well, death means something different now, it means less than or equal to 2, I change it in one place, and now both NPCs and players benefit from that change. All right, so understand the kind of the rationale for where we put things. In this case, we have 2 different objects, NPCs and players, that both come from inhabitant. If they both get the same feature, put it in inhabitant. If they both almost get the same feature, sometimes we might say, well, they both might be dead under a certain case, but we might want to do a little bit more for player or something like that. You can write it in inhabitant, and then you can add, you can override it in player, and then add a little bit more logic to it. I'll at some point we'll have an example of that. Go ahead. Oh, almost had an emergency. I thought I'd forgotten my soda in my car. I guess who was going to be making a trip out to my car?
Yeah, I'll do it. Might not come back.
Extra credit.
Yeah, extra credit that one.
All right. because my knee only goes up that staircase once per day. That's the rule for my leg. All right. So so in any case, we've added is dead to the inhabitant. So now we can ask any inhabitant if they're dead. Okay. Go back up to Deathmatch. So in our fight, rather than asking if the attacker's hit points is greater than 0, we're going to say if the attacker is dead. Okay, so that's going to return true if they are dead. So we're going to ask if the while the attacker is not dead. All right. Now, we could have written a convenience function called isAlive inside of inhabitants that return whether or not they're alive if we don't like this logic. So we can come down here to inhabitant and just give ourselves another little convenience function. So we can ask if they're dead, but we can also ask if they're alive. isAlive. And this will return self.hp greater than 0. They're alive if it's greater than 0. We could have also said return not self.is dead. That would do the same thing. So these two lines would accomplish the same thing in here. The first one is written in terms of one of our other functions. So this says call my is dead function and return the inverse of it. If it gave me a true, return false. If it gave me a false, return true. Or we could just say, well, isAlive means my hit points are greater than 0. Choose your poison. Doesn't necessarily matter. I'm just showing that we can create these little conveniences. This was pretty easy, right? Nothing super special about that. It's a little ability we gave to inhabitants that now allow us to ask the question in a little bit cleaner way up here, because now we're saying if the attacker is alive. See how that reads better? Even though we know under the hood, inside of our inhabitant here, there's some wires that give some logic to what isAlive means. But when we call that function out here that we just wrote, it makes some sense as we read it. So as long as the attacker's still alive, let's do some attacking, right? Okay, so we decided that when the attacker attacks the defender, he has to first see if he clears the defender's defenses. Okay, so along the same lines as what we've been doing right here. Check the time here real quick. Okay, we're out at 11:20, right? Okay, good. We got plenty of time. All right. So while the in order for the attacker to do damage to the defender, we must first try to have the attacker hit the defender. All right. So now we mentioned that we're maybe going to roll some dice. Okay, remember before we had written a dice roller? Okay, but we kind of, that's no longer in our code here. So let's just go ahead and write a quick dice roller and give ourselves an object that we can create D20s, D6s, stuff like that. So I'll go ahead and create a class dice. Probably could be called die, but dice I think reads better. And this will be def init self number of sides, and we'll set self side, we'll call it number of sides. We'll just do the whole dealy here. It's equal to number of sides. And then we'll have def roll. And this guy is going to roll a number between 1 and the number of sides. I think we've already imported random here. So we'll go ahead and return random.randint of 1 to self.number of sides. And I think that's inclusive for randint. Okay. So now we have a dice object that allows us to generate a 20-sided die or a 6-sided die or something like that. And we'll go ahead and test that real quick, make sure it does what we want it to do. So down here in my code, remember last time I just put a while false in there so that makes sure this code won't run. Otherwise you can just comment it out. I don't know if, does this thing allow you to do multi-line comments? Let me just look it up real quick. I think it's like 3 pound signs. They just put a pound sign before each one. I'd like to be able to, oh here, multi-line comments. See, in C, C++, Java, you can do that. You put all the stuff that you have comments in between there. Triple quoted strings. So ... Okay, let's see if that does it. Yep. So I can switch that back to true, because this is what I really want the code to be, but I want it to be ignored for right now. So I could put 3 single quotes before it, 3 single quotes after it, and it treats the entire thing as a comment. So just a way to get it out of my code for a minute here. All right, and we tested this last time. So those are NPC stuff. So we can just get rid of that for right now. What I'll go ahead and do is let's just roll, create a D20 and roll it 20 times or something like that. So I'll say D20 is equal to dice with 20 sides. And I'll say for I in range 0 to 20, print D20.roll. And just make sure we get values in the range of 1 to 20. Check this chat message here real quick. This is a very, very violent class. Oh, I haven't finished writing. Just ignore that for a minute. Oh, did it not actually like the these ... things? Yeah, didn't actually like them. Looked like it was going to like them, but didn't actually like them. So, I don't know. Did they give me another option in here? Oh, make sure to indent the ... I get it. So it did work. We just need to make sure we indent those so it doesn't break the indentation part of it. All right, there we go. So we get a 20 out of it. I'm sure we'll get a 1 out of it somewhere. I don't know if we ran it enough times. There's our 1. So it looks like our D20 is doing what it's supposed to be doing. All right, so we created a dice object. We just tested it real quick to make sure it behaves. All right, so now what we want to do is we're going to go ahead and build in some abilities to our NPC and player for them to try to get hit, right? So we find out, we ask, did this hit or something like that, or, successful attack, was successful attack, something like that. And successful attack is going to take in a value and will return true if that attack was great enough to equal or better their armor class. And since that's something that both NPCs and players need to be able to do, we're going to go ahead and write that into inhabitant. All right, so inside of inhabitant, we'll say def was successful attack, something like that. We'll call this guy an AC roll, armor class roll. So was successful attack should return true if the attack was successful. And the attack is successful if this guy right here is at least as big as this guy's armor class. So return AC roll greater than or equal to self.ac. That's what was successful attack will do. Okay, so if I go and take a swing at the NPC and I roll a d20 and I get a 9, and then we ask the NPC, was that a successful attack? The NPC, I give him the 9, he responds back saying, yeah, you hit me. His AC might have been 8 or 7 or whatever it was. So he returns true, it was a successful attack. And upon successful attack, we want to then do some damage, right? So def, maybe call this guy take damage. So any inhabitant knows how to take some damage. So we'll call this amount of damage. And what do we do with the amount of damage? We reduce our hit points by that. Self.hp is equal to self.hp minus amount of damage. That's what taking damage means. Okay? But just like all inhabitants can take damage, all inhabitants should be able to do damage, right? And what does do damage mean? A do damage says that I'm going to do damage says that I'm going to roll an amount of damage. I think we decided it was going to be a D4 plus your strength modifier and get that amount of damage. So we'll say this is def do damage. And maybe what we do is when we do damage to an opponent. Okay, so we'll do damage to the defender. We'll go ahead and create a D4, which is a 4-sided die. And then the amount of damage we're going to do, we're going to say defender, take some damage. How much damage? D4 dot roll amount of damage plus self dot strength, my strength modifier. So our defender is going to take some damage. How much damage? A D4 plus this person's strength modifier. That makes sense? And then what we can do is we can actually build a function into inhabitant called attack that takes in a defender and tries to attack that defender. So it builds in this logic of using these other things. So we can say, in fact, actually, let's say I'll just write the beginning part of it here. def attack self defender, this guy should attempt to attack the defender, and if successful, actually does damage. That's what this attack should do. Okay, and I think you have all the pieces you need to do it there. So take a couple minutes and try to write this attack function that will have this guy, self, attempt to attack defender, and if he was successful, he'll actually do some damage to that defender. All right, take a couple minutes and try to write that. All right, let's take a look. All right, so when self, which is this particular attacker, is going to attack the defender, they need to roll a d20. So we're going to need a d20. And we'll go ahead and get our attack roll will be equal to a d20 dot roll. Then we want to ask if we had a successful attack against our defender. If defender dot was successful attack, and we're going to pass that our attack roll. If that's true, if we did have a successful attack, then we want to do damage to the defender. Else, if we want to add a little commentary in here, we could do something like print, you swing and miss. Something like that. All right, and then just to test this, we'll go ahead and we'll create our player. We already had him in here, but we'll say P1 is equal to player, and we'll say Mike, and then NPC1 is equal to NPC, and this probably should be Ben. Man, if so, and I get 5 attacks for every one attack. So we'll say P1 attack NPC1. It reminds me of any of you, this might be before your time. Any of you see the movie Space Jam? Michael Jordan, Bugs Bunny, all the. I remember the quote from the guy who played Newman in Seinfeld. He says, "Michael, put me in. I'm not just fat, I'm slow." Great quote. Hence the reason I get 5 attacks. So P1 dot attack NPC1. I'm going to go ahead and I'm going to display. I think we gave a display for these guys, right? So we'll display both of them beforehand, and then we'll show NPC1 afterwards, hopefully seeing some damage, right? Oh man, cracked you. Look at that. All right, so we both started off with 10. I had 10 hit points. He had 6. I had a 3. Man, I had like no armor class. I literally rolled a 0. Hey, so then I had you had a higher armor class. We both had strength modifiers there. All right, so I tried to attack and I was successful and I hit him for 5. So now he's almost dead.
My max hit is only 8.
Hey, I don't care. You didn't even get to swing.
I know.
All right, so let's see if we can get a swing and miss on this one. There we go. So we got a swing and miss. So I tried to hit him. I missed, and notice that his hit points are still what they used to be. All right, and here we'll let him get 1 swipe in. So we'll say NPC1 dot attack player 1, and then we'll say player 1 dot display afterwards. Oh man, look at that. After you died, I one-shotted you.
Well, I only have 4 HP.
Hey, look, I don't want to hear excuses. Is all I'm saying. All right. so now we have some moving pieces for our MPC. So hopefully you kind of see the way object-oriented programming works is at kind of the core level, we just add a bunch of abilities to our objects, and then we can then use those abilities. I like to think about this as kind of like I went to Home Depot, except we're also making, since we're the programmer, we're making the products at Home Depot, right? But we built into inhabitants the ability to attack another inhabitant, the ability to display ourselves, the ability to take damage, the ability to check to see if it was a successful attack. We created all these little mini abilities, and then we can call upon those abilities in the right order and accomplish real tasks. This kind of goes back to our early in the semester conversation about CPUs. What's a CPU? It's a collection of magic tricks, a collection of little tiny things. Some of them do more or less than others, but relatively simple components. And we call multiple of those magic tricks in a row and real things get accomplished. Okay, if you remember that, the example where I said, okay, everybody wiggle their thumb, okay, then wiggle the rest of their hand, and neither of those things are overly important.
According to Healthline, shaking in your thumb is called a tremor or twitch. Thumb shaking isn't always a cause for concern. Sometimes it's simply a temporary reaction to stress or a muscle.
Perfect. All right. But when you put those things together, you're able to accomplish a real task. So we're almost trying to capture the same thing in our programming with object-oriented programming, where we're moving those details, kind of the logic, but those kind of the small details inside the objects, so that when we actually utilize those objects, we can just say, hey, player one, attack NPC one. Do whatever that means to attack. And then if we go and look at that attack function, we'll see that he tries to attack. If successful, he actually does damage. If unsuccessful, we print out you swing and miss. Make some sense? Okay, so for our homework, finish implementing Deathmatch such that it will have 2 inhabitants fight to the death and announce who won. Make sense? And I'll give you our current code here as a starting point. Start code for Deathmatch homework. All right, so my current version of the code is up on Slack. I'll put this assignment up. It is due on Tuesday. Questions about what I'm asking you to accomplish? Shouldn't be too bad. Just keep following the same little pattern. Hopefully you're seeing here that if you look at this whole program, things are getting pretty big. We have lots of lines of code there, right? But all programs are made up of a bunch of easy parts. If we look at just this piece, that isn't a big deal. If we look at just, let's pick something we wrote today. If we look at attack. Attack in and of itself is one of our more complex methods, but when you look at it, it's not doing anything crazy, right? So you got to take things one step at a time and kind of let your solution grow. All right, questions, comments, concerns, bribes. I see a little chat here. All right, I'll see everybody on Tuesday.